understanding of the sun has evolved greatly over time. Throughout history, humans have been fascinated by the sun and have built religions around it. Bronze Age Norse civilizations believed that the sun was drawn through the sky on a chariot pulled by a divine horse. A model of this sun chariot was dated to around 1400 before Christ. Similar beliefs were shared by the ancient Romans, who believed in a sun god called Helios. Helios carried the sun above his head and drove across the sky on a 4-horse chariot. These religions tried to give explanations regarding the complex natural phenomenon that is our sun. One of the most famous beliefs about the sun and the planets was that they orbited the Earth, which was placed at the center of the universe. This worldview is known as the geocentric model and dates back to ancient Greek times. It would take 2 millennia for Polish scientist Nicolaus Copernicus to develop our understanding of the sun. He suggested that the Earth was not in fact the center of the universe, but instead orbited the sun along with all the other planets. His 16th century heliocentric model has meanwhile been verified with modern-day technology. Modern scientific development is driven by NASA. NASA launched a series of 8 orbiting satellites between 1962 and 1971 in order to examine the sun. They provided the first high-quality observations of the sun in ultraviolet light, among other achievements. In 1990, NASA and the European Space Agency launched the Ulysses probe to make the first observations of the sun's polar regions. NASA's Genesis spacecraft returned samples of the solar wind to Earth for study in 2004. The Parker Solar Probe is NASA's most recent quest for knowledge. It was launched in 2018 and got as close as 6.5 million kilometers to the sun. It will provide new data on solar activity, like how energy flows through the sun, the structure of solar wind, and how energetic particles are accelerated and transported. Even after answering many questions, for scientists, the probe is likely to generate more questions than it answers. Today, we know that the sun was born about 4.6 billion years ago. Our sun was formed out of a giant rotating cloud of gas and dust, known as a solar nebula. Just like most other stars, the sun's mass consists of almost 3/4 hydrogen and 1/4 helium. Nearly all the remaining mass comes from 7 other elements such as oxygen, carbon, neon, nitrogen, magnesium, iron, and silicon. The sun's statistics show us a large amount of energy which it is capable of producing. It has a temperature of 5,500 degrees Celsius, which is a relatively average temperature when compared to other stars in the universe. The great temperature largely comes from the sun's utilization of fusion to generate energy. Fusion occurs when 4 hydrogen atoms experience a series of collisions, causing them to fuse with one another to form a helium atom. The mass of a helium atom is slightly less than that of 4 hydrogen atoms, thus, during fusion, this missing mass is converted to energy. The sun fuses 500 million tons of hydrogen each second. The diameter of the sun is around 1.4 million kilometers, with its circumference being nearly 4.4 million kilometers. In terms of the galactic timescale, the sun is quite young at around 4.6 billion years. It is around halfway through its lifespan, meaning it will change form after another 5 billion years. The gravitational pull from our sun is what keeps all the planets fixed in an elliptical orbit around it. This gravity can also pull in asteroids and other pieces of space debris into the region of our solar system. Once a comet or an asteroid has been captured by the gravitational pull of our sun, it will orbit in an elliptical orbit as the planets would. The sun's magnetic field has 2 poles, like the Earth's. Every 11 years, these poles flip, or swap places. This happens at the peak of each solar cycle. The poles flip as during this time period, there's a lot of activity in the magnetic dynamo of the sun. A dynamo is a mechanism which allows large celestial bodies, such as the Earth or the Sun, to generate a magnetic field. This occurs thanks to the large amount of fluid metal flowing about in the core of these bodies, creating electrical currents that generate the magnetic field. The heliosphere is a region of space around the Sun which consists of electrically charged gas flowing out of the Sun. This stream of particles engulfs all the planets in the solar system and acts as a shield against cosmic radiation. As the Sun rotates, this stream, or solar wind, is wrapped around it like a spiral, which then spreads out to the rest of the solar system. The Sun consists of 3 main regions: its interior, atmosphere, and surface. These regions then split into different layers. At the center of the Sun's interior is the core. It is the hottest part of the Sun, reaching up to 15 million degrees Celsius. It is here where the fusion takes place, fusing hydrogen nuclei into helium. After the core comes the radiative zone. This is a layer in which energy is transferred further out in the form of photons as thermal radiation. The next layer transfers the energy through convection currents. It is called the convection zone. The surface of the Sun is its photosphere. It is the layer of plasma we see here on Earth. Moving into the solar atmosphere, we have the lower region, the chromosphere. It is a less dense layer of plasma. The upper region is called the corona. It is even less dense plasma, sitting at a maximum temperature of more than 1,000,000 degrees Celsius and extends many thousands of kilometers away from the Sun, gradually turning into solar wind. The two regions of the solar atmosphere are connected by the transition zone. It is here where the drop in density and rise in temperature occurs. As it is a relatively thin layer, this change happens rapidly. During the 11-year solar cycle, periods of increased solar activity can be observed. These usually occur during the end of a cycle where the poles swap. Sunspots are an indicator for this increased activity. They are regions of stronger magnetic fields relative to their surroundings. With these sunspots come other indicators of more solar activity. Solar flares are the result of magnetic fields getting too tangled with one another, creating explosions which send out massive amounts of electromagnetic radiation. Coronal mass ejections are also a result of heightened activity. They are massive amounts of solar plasma being catapulted into the solar system. The Sun doesn't just shoot deadly plasma in our direction, it provides us with the necessities for life. The Sun constantly emits electromagnetic radiation. Some types of it are essential for life, others are harmful. Infrared light provides the heat required for us organisms to live, whilst the visible light enables photosynthesis, the foundation of life on Earth. Ultraviolet light is the opposite and is harmful to living tissue. It is mostly filtered by our atmosphere. The Sun won't always be there, as there will be a time where it eventually runs out of its hydrogen fuel. After about 5 billion years, the Sun will have consumed all the hydrogen in its core. This will turn the Sun into a red giant, which will have consumed our planet along with others. Once the rest of the fuel gets consumed, the Sun will shrink into a white dwarf. Once that phase comes to an end, the Sun will explode into a planetary nebula.